Hello. As a first task, if we want to start programming or scripting in Python, we need to get Python onto our system. There's different ways of doing this, and in this short video I'm going to go through a couple of them. This of course depends on which system you are running, if it's Windows, Mac or Linux, as in my case. So if you go to the python.org homepage, you find that there is a download section, and if you click this button to download the latest Python, you come to this page, and it's all free and open access and open source software, so that's nice, of course. But we see these files, the source code files here, and different packages for Windows. And the first thing you need to know about Python is that it's a vastly, if you click about, you can read up a little bit on Python, what it is, and it's a vastly modular language. So with only Python running, you are not going to get far, at least not in data science or in earth system science if you want to use it for sciences, science data analysis and so on. So what we are going to do is to install our own system, which makes it easy to get all these modules, additional modules, except the core Python that we need, and I'm going to show you how to do this. So please read up on what Python is. There's also some great documentation here about what Python is, how to interface with it, how to learn to code it properly. I would in particular want to highlight the PEP index, especially the PEP is the Python enhancement proposals, and especially there's a PEP number 8, which we can see here, the style guide for Python code. It's worth having a look on how to actually code Python in a more uniform way that other people might find it easier to read your code. And it helps to clean up your code for yourself as well. So I'm going to do two different things. Depending on which system you're on, you might want to do one or the other, or both. This gives you a kind of different setup for your system, but in the end result will be the same. So instead of using the raw Python, which only contains the core Python code, we're gonna go to Anaconda. Anaconda is a package basically that includes a lot of Python products and package them all together nicely to for different systems. So we go if you go into products, you see the individual edition, which is the open source distribution. There's also some enterprise ready versions that you might choose from. We're going to go with the individual edition, and if you click there, you land on this download page, and you can read up on this, please do. And if you just click downloads or get the additional installers down here, you see that there's for different operating systems there's options. If you're on Windows, depending on your system architecture, choose 32 or 64-bit depending on your preferences. Same for Mac, and for Linux there's different options. I'm gonna go with this one, and if I'm clicking and I'm going to click and download this, and this is, as you see, 581 megabytes, and this is just the core, the packaged. This is similar to across all the systems, and this is just the packed version basically. Once you unpack it, once it's installed, it's much bigger. This is because Anaconda includes a lot of, let's call it overhead, packages, modules that you might not need, but they are already installed anyway. This is great for beginners, so I recommend you do this if you don't want to get too deep into Python. So let's into the Python setup for your own. If you run Python, the Python setup yourself, if you we're going to do this later, you'll see the difference in size that takes this up in space on your disk. So for now, let's choose for your system which one you want to install and install it. I'm going to go ahead for this Linux. I'm going to download it, and I already saved it, so just save it. And then I'm going to open up a terminal, and I see here I downloaded it already in the Anaconda 3 version, and I'm going to make it executable. This is a Linux specific thing. So let's do this, and now we can execute it, and as you can see, we can install it. So you have to first review the license. Even though Python is a open source and open license program. Anaconda has some strings attached to it. And please go over this end user license agreement in detail. So once you finish reading this, you can exit this, and you are asked to, if you are accepting the license. Yes, I do. And then the path is asked where to install it. The basic standard default path is it's fine for me, so just enter, and now the install starts. The nice thing about Anaconda is you don't need a super user or admin account to do this. So even if you're on a system where you don't have super user rights or admin rights in Windows or Mac, then you can still install it, and it's running completely in user space in this folder. As you can see, I'm user tutorial right now, and this is just in one folder. If you delete this folder, everything is removed from your system. It's a nice idea to keep this, your working Python project, basically separated from your system Python. So it might actually be that you have different versions of Python running on your system depending on for your different projects. In Linux and Mac, there's already a Python installed, which is used by the system itself. Not so on Windows. But you want to keep this separated. For example, you want your scientific Python to be upgraded to the newest version maybe, and this might not be the best option for your system, because then things maybe run out of line. So it's a good idea to keep this separate. That's why we're doing this install. Yes, and we want to, if we now, after this, the question here, do you wish the installer to initialize Anaconda by running conda init, basically means if you start after this, if you click yes, then after this every console you open will start in the default Anaconda environment already. Let's go with yes for now. Okay, so this is finished. Let's see, we have now a Anaconda folder 3 here, and if we close this and open up a new console, we see now that we have here this base in the beginning here. We didn't have that before. This base means we are now in the base or in the default Anaconda environment. So if I'm typing now just Python is installed in the version I downloaded. So this is Python version 3.9.7. To prove to you that this is different from the system Python, I'm gonna exit this here. I'm gonna conda deactivate this environment and deactivate, and now you see the base in the beginning disappeared. So now if I'm typing Python, you see I'm running Python 2.7.16, which is the default Linux Python running on my machine right now. So we can also do this. We can also do this with, if we look at which Python is actually running. So which Python is running. This is, as you can see in Linux, the user bin Python binary. And if I go out of there, open up another console, then we see we're now again on the base Anaconda base environment. And if I type now which Python here, you see this is the Python binary out of the Anaconda package. So with this, Anaconda is installed, and we can now start the Anaconda navigator. If we do this, there's some warnings probably related to my display with recording this. So you see the Anaconda navigator is starting up. It should look in your system similar to this. If you are running Windows or Mac and you installed it by the binary, in your start menu you will also have the Anaconda navigator, and can just click on it and you should get the same result. So, and you have different options, different programs here that are already ready to launch. There's also additional ones that you can install. And if you click on the left hand side on environments, you see that the base environment here currently is selected, and here you see a list of all the packages that are installed at the moment. Obviously you can search for new packets, and we'll do this later, and install other packages that you might need at some point. Okay, this was as easy as it gets to install Anaconda. We can now, if you go on home here, for example, you can start a Qt console, If we start this, we now get a nice Qt console in which we can run Python, for example, print hello. And Python is running. We're going to go into all of this later. I'm going to close this. Yes, close all. So, as I said, Anaconda has a lot of overhead. What do I mean by this? If I open up my terminal, any terminal, and I look into the Anaconda folder, and I see how much disk space it takes up, I see that it's currently 4.1 gigabytes on the disk, just for the Anaconda environment. So let's see if we can reduce this a little bit. And this is a a Linux specific thing. It will also work on Mac, but on Windows I will recommend you use Anaconda because it's a bit of a pain to set this up properly. It's totally doable, but then please read up on this yourself. So instead of using Anaconda, I'm gonna go conda deactivate to deactivate this current environment, and now I'm just on my normal system. And what we can use instead of Anaconda, so let's close this down for now. So instead of Anaconda, what we can do is use something called a virtual environment for Python. So I'm gonna install my own little Python environment that you can then use to do all your work in. And this is done in the normal way in Python 3. And if I just load the module venv for a virtual environment, and then I have to give it a name. Let's call it myPython. Sorry, myPython. If I do this rather quickly, I see that in my home folder now I have a folder myPython. And if I go into this folder myPython, I can see there's some folders in there like bin and include and libraries and so on. In order to activate this, similar to the Anaconda thing we had with the base environment before, I can just source the activation script, which is in the bin folder. So in bin there's an activation script, and you can, if you source this, basically meaning run this, you see instead of base for the Anaconda, we're running now our own little environment independent of Anaconda on your system. And if I look how large this, and I can now of course see first of all which Python am I using, and I'm seeing now I use the Python binary in the myPython folder. So if I just now execute Python, I see I have also the current 3.7.3, so not the system Python, which was 2.7, but a newer version, but the highest version that my system Python 3 allows to be installed. This is a little bit of a technicality. You can go up with the this depends on your system basically, which kind of version you're installing here, but you can update it if you like. So let's get out of there and let's see how, because this is a working environment. I can show you. We can also do a little print hello here, and it says hello, right? I can do 1 + 1 and it's 2. So this is Python already working. So I'm going to exit this and let's have a look at how large our file folder is here. This whole myPython environment is just 6.7 megabytes. Compare that to the 4.1 gigabytes of Anaconda. However, if you want to install, you have to install multiple packages. This is just the core Python basically. If you want to have more packages like numerical algorithms and so on, which we're going to use later, you need to install them on top of that, and that will of course increase then the size of this folder. However, this is like if you want to go for small sizes and optimized systems, this is definitely the way to go. Okay, this uses this environment. For example, if I want to install now a package, let's say for example I want to do numerical computations, I'm going to use a package that's already installed in Anaconda, and I have to install this. Just to quickly show you how to do this. So for this you need pip. I can look at which pip it is, and I see pip is the pip Python packaging index program that is in this myPython environment. So I can just type pip install, for example, NumPy. NumPy is a module or a package or a library that is enhances Python, the core Python, to include arrays and similar as a MATLAB functionality. So if I do this, this will be downloaded. You see it's packed, it's 10.6 gigabytes, and there might be some additional dependencies that are already that will be installed automatically. We'll wait for this to finish, and then we're going to go into Python, and I'm going to show you that it's already then there already and ready to use. Okay, this took a second, and now it's finally installed. Successfully installed NumPy 1.21.4. So if I now go into my Python environment, I can import this module that I just installed, import NumPy, and I can see that the NumPy.version is NumPy. It's the 1.21.4. So this is just how to set up your own environment, but we're going to go back to using Anaconda for the sake of everyone who is on other systems, that we have a combined or a similar system set up for everyone. Okay, I'm going to go out of here and go back into my Anaconda navigator.